All right. So now let us see some concept which is related to our civil engineering. Okay. So whenever you are solving any problem using say matrix method or maybe finite element method, you always end up with a stiffness matrix equation. Okay, which we generally call it as a stiffness equation. So that stiffness equation is nothing but K, which is usually called as stiffness matrix, into delta, that is unknown displacement, equals to, we have force. Okay, this is a very simple thing, right? So for example, if I take a simple truss kind of a structure, which is probably like this, okay, Aja. And we have one joint over here, one joint over here, and one joint over here. Okay, so here in the truss, only axial forces are there. Okay, and we have degree of freedom. So we have two degree of freedom. One is dx and second is dy. That is, every joint is possible to move either in x direction or in y direction. Okay, so this is, I'm talking about 2D. If it is a 3D truss, then dz will also come into picture. Okay, so now if you generate a stiffness matrix for this particular problem, so you will end up with a stiffness matrix for member 1. Okay, so this will be your member 1, this will be your member 2. Okay, so so member 1 will be having a matrix of size say 4 by 4. Member 2 will be having a size matrix size of 4 by 4, and if you assemble it, you are going to end up with a matrix of size 6 by 6. Okay, so this K matrix will be a 6 by 6 matrix. Okay, but when you apply the boundary conditions, so you can see this particular end, that is this end and this end, they are fixed. Okay, this means what? Your dx and dy, they are 0. So if you or I should say that if you eliminate the rows and columns of the supports, so your reduced stiffness matrix, so this will be K reduced will be of size only 2 by 2. Okay, because you have only 1 degree of freedom over here and 1 degree of freedom over here. Okay, so what is going to happen over here is, so this particular K matrix will be of size 2 by 2. Okay, and here you will say dx and dy, only two possible displacements are there. Okay, equals to, okay, equals to force in x direction and force in y direction at this particular joint. कौन से joint पे? ये वाले joint पे. ठीक है? So now if you want to analyze this particular truss, you should have some force on that joint. तो ही आप उसके अंदर के member forces निकालोगे ना. Otherwise वो तो solve होगा ही नहीं, because there won't be any forces. So I'm trying to say over here is this particular matrix, that is K matrix, will be known. Okay, and this will be also known. Okay, so this will be an external loading. So either it can be in x direction, it can be in y direction, or it can be in the both the directions. Okay, now so basically if you rewrite this particular equation, so this is nothing but a into x equals to b. Okay, so from which this is known, this is known, this is not equals to 0, this is also not equals to 0. So there are some values, non-zero values. Okay, now this type of equation is called as non-homogeneous equation. Okay, this is called as non-homogeneous equation. Now, the basic property of non-homogeneous equation is you have a solution. Okay, just now we have seen Gauss method, we have seen Cholesky method, Gauss-Cholesky method, Seidel method we have seen, right? So all these method, they are going to give you one solution. Okay. So if I give you some problem which is non-homogeneous in nature, where you have some matrix A, you have some matrix, some vector B. So you use either Gauss elimination method, Cholesky method, this method, that method. You are always going to get only one solution. Okay. So there is a set of X. Okay. That is X1 and X2. There is only one set of X which exists, which satisfy this equation. Okay. There is only one solution. There is no other solution. You use any method, there is only one solution. This is the property of non-homogeneous equation, right? Now, if this is non-homogeneous equation, what is homogeneous equation? Okay. In homogeneous equation, what happens is like this. That is A into X. This will be 0. Okay. So the vector, which is the product of A into X, this is always 0. So this particular thing is called as homogeneous equation. Okay. So now this homogeneous equations, basically they comes under the eigenvalue problems, right? Now if you refer to that particular truss, what is your A? A is nothing but your K matrix, that is a stiffness matrix. And if you refer to the X, X is nothing but your unknown displacements. Okay. And if you refer to your B matrix or B vector, it is what? B vector is nothing but your force vector. So basically here we have a truss which is having no forces at all. अब ये situation कहाँ पे आएगी? Usually what happens is whenever you are solving a problem, you have an external loading. You have a support. It can be beam, slab, whatever it can be. Okay. Now where this no load condition will come into picture. Now this usually this no load condition comes into picture when your stress or your structure is subjected to some kind of a vibration. Okay. So let us say in the event of earthquake, what is going to happen? There won't be any load. Okay, your structure will be there. If you ignore the self weight, there is no external loading. Okay, so in that particular case, this B matrix is basically 0. But during the earthquake, your structure is still moving. Remember, okay, your structure is still moving, and you don't know how it is going to move, because if it totally depends on your intensity of your earthquake. If your intensity is more, the structure will deflect more, isn't it? If intensity is less, the structure will deflect less. Okay. That too, if the frequency is different, the behavior of the structure may be different. Okay. So this is a random vibration, a random type of a problem. So here you have a stiffness matrix, you have an unknown displacement, but there is no external force. Okay. So for example, if you take the same problem, the truss problem, during the event of earthquake, your truss may deflect like this. Okay. Or your truss may deflect like this. कुछ भी हो सकता है. Okay. So this is what is nothing but the eigenvalue problem. So here there are more than one set of X exist that satisfy this equation. So basically here the solution, that is X, unknown displacement, it is not fixed. They are changing, they are varying. So there can be one set, there can be another set, there is one more set that satisfy this particular equation. So that's why you are getting different deformations. Okay. So this is what is your eigenvalue. Have you understood this? ठीक है. तो इसका एप्लीकेशन सिविल में बहुत ज्यादा है. Okay. Especially when you go for PG, that time you realize कि this has to be solved, right? So now how to solve this? This is what we are going to learn in this particular subject. Okay. So there are several methods. The very first and very basic method which we are going to study today is a direct method to find out the or to solve the eigenvalue problems. Okay, so we'll start with the direct method now. Okay, okay, direct method, right? So now, like I said, we have a matrix into x. This is equals to 0. Okay, so this is what we call it as a homogeneous equation. Okay, we have now one homogeneous equation. Now how to solve this? Okay, so for solving this, what we are doing is we are going for a simple expression, which is we are assuming a identity matrix, that is A. So this is A minus lambda into I equals to 0. Okay, so this lambda is nothing but your eigenvector. Sorry, eigenvector, right? No, eigenvalue, not eigenvector. This is called as eigenvalue. Now, with this, we can solve this. So, for example, if you have a matrix of size, let us say 3 by 3. Okay, so whatever values which are given to you, all you have to do is just take this lambda and then I is basically your identity matrix. Okay, so this identity matrix is nothing but something like 1 1 and 1, and the upper triangle will be 0 and the lower triangle will be 0. So this has to be equal to 0. Okay, so in this particular way you have to find out the uh, value of lambda. Okay, so now to understand this, what we are going to do is we will take a simple numerical. Okay, so I think I have a solved numerical with me. Just a moment, huh? So basically uh, where is ah, so we have one problem over here. So once we solve the problem now, then you will understand. Okay, so we have a simple problem which says that is 3 10 5. Okay, this is minus 2 minus 3 minus 4, and this is 3 5 and 7. Okay, into you have x1 x2 and x3. Now the fourth term is basically 0 over here. Is it okay? Okay, so now so now in this case, what we are going to do is we are going to introduce one term called as the eigenvalue, that is lambda. Okay, so here if I rewrite this particular expression, so I'll get something like this is 3 minus 2, this is 3 10 minus 3 5 5 minus 4 and 7. Okay, and this now this matrix will be replaced with something like lambda into 1 0 0 0 1 0 0 0 and 1. Okay, so this is one term. Okay, multiplied by you have x1 x2 x3. Okay, equals to we have 0 0 and 0. बराबर है? So now you see we have a product of two terms. Okay, one is a minus lambda times I. This is first term. So here, let me write down. This is your first term. Okay, and this is your second term. Okay, So when you multiply first term with the second term, what you are going to get is 0. इसका मतलब क्या हुआ, या तो पहली टर्म 0 है या तो दूसरी टर्म 0 है, बराबर है. Okay, so you cannot have x1, x2, x3 as 0 because they are the unknown displacements. So this possibility is completely gone. So this the second term, this second term so this second term, this cannot be 0, बराबर है. But there is a possibility that this first term may be 0. Okay, so depending on this possibility, now we have to rewrite this expression, which is like this. So this is 3, 10, 5. Is it 10 or 16? It is 10 only. Okay, so this is 10, 3, 10 and 5. This is minus 2, minus 3, minus 4. This is 3, 5 and 7. Okay, minus we have lambda times 1, 0, 0, 0, 1, 0, 0, 0 and 1. This has to be 0 because the other possibility is not at all there. Okay, so this has to be 0. So now we have established one relationship. So based on this, let us expand. So if you expand this, what you should get is something like this. So this is 3 minus lambda. Okay, then we have here, it will be 10 only because 10 minus lambda times 0. So this will be 0. Then this will be again 5 minus lambda times 0. बराबर है, ठीक है. So the other terms, they will remain same. This will be minus 3 minus lambda. This will be minus 4. This is 3. This is 5. This is 7 minus lambda. This has to be 0. Correct है, ठीक है. So here the entire matrix has to be 0. So this entire matrix means what? We have to find out the determinant. I hope you understand the meaning of determinant. So the determinant of this matrix has to be 0. So can anybody tell me how you calculate the determinant? So we just go with the diagonal term. Okay, so let me write down. So correct me if I am wrong. Okay, so you write this first term सबसे पहले. Okay, so you write here something like 3 minus lambda. This is the first term multiplied by the multiplication of these two. Okay, so this is basically minus 3 minus lambda multiplied by 7 minus lambda. Okay, no, this is half. Then minus the multiplication of these two. Correct? So this is something like minus 4 and 5. Then, okay, I hope this is correct. Okay, then next what we have to write? Minus 10 बराबर है into the product of these two minus product of these two. Is it so? So this will be something like minus 2 into 7 minus lambda minus minus 4 into 3. Okay, उसके बाद क्या आएगा? प्लस आएगा माइनस आएगा? प्लस आएगा. प्लस. So 5 into product of this minus product of this. So this is basically minus 2 into 5 minus 3 into minus 3 minus lambda. This has to be equals to 0. Okay, so now you have a big task ahead of you. You have to expand this equation and since it is a 3 by 3 matrix, so you will get a equation which is having lambda to the power 3 plus or minus lambda some factor into lambda to the power 2 plus minus lambda then some constant. Okay, so please do this and expand this. Okay, so here you have to solve this. Okay, don't solve this, I have the solution with me, just listen to me. Okay, everybody please pay attention, please stop solving this. Okay, so now see, you have if you solve this, okay, so you are getting some value into lambda to the power 3, okay, plus some value lambda to the power 4 plus some value lambda plus lambda to the power 1 and plus some value. Okay, so this is a cubic equation. Okay, so and this has to be equals to 0, of course, this has to be equals to 0. We have already studied a method like bisection method. We have already studied regular policy method. We have studied Newton-Raphson method. 3 methods we have already studied to solve this particular equation. Okay, so you can use those methods to find out all 3 roots. Okay, because you see it's a cubic equation, so it must have 3 different possible alpha values. Okay, so I'm just reducing your work. I have already solved this. Okay, and if I take this, if I solve this, so I should get it in this particular form. So this is, if you solve this, okay, so after solving, I am getting a simple expression 3 minus lambda into, this is lambda square minus 4 times lambda plus 4 equals to 0. Okay, so I have solved this and I have not exactly solved this, I have reduced this. Okay, I have separated some of the lambda terms. I think the same equation is there, so you have a reduced form of that equation, and I'm sure if you multiply 3 minus lambda with lambda square minus 4 lambda plus 4, you will be definitely getting lambda to the power 3 equation. Okay, so why I have reduced this in this particular form? Because now you have again 2 products, one part and second part. So one part can be 0, second part can also be 0. Okay, so here one possibility is this is 0, another possibility is this is 0. Okay, so if I consider the first possibility, this means 3 minus lambda is 0. So this is meaning what? Lambda value is basically 3. So this is the first eigenvalue which we have obtained. Okay, now the second possibility is something like lambda square minus 4 lambda plus 4 equals to 0. Okay, so this is a second degree equation. So you can solve this using a simple rule, minus b plus minus under root of b square minus 4ac divided by 2a. Okay, so you can solve this, and if you solve this, you are going to get 2 values. Okay, you are going to get 2 values. So one value of lambda and another value of lambda. So I have already solved this, and after solving I am getting both values as 1, same, both values are same, that is 2 and 2. So now I can say there are 3 eigenvalues. One eigenvalue which we call it as lambda 1, its numerical value is 2. The second lambda value is lambda 2, its numerical value is 2, and the third lambda value is lambda 3 and its numerical value is 2 once again. Okay, so basically what is happening in this equation is most probably like this. Okay, So if you plot this particular equation, you may get a curve probably like this. So we have a touch and go situation over here. So here this value must be 2 and this value must be 3. Either this way or the mirror image. Okay. So mirror image means what? So it is going like this. So either this is 2 and this is 3. इन दोनों में से कोई तो भी इसका एक पैटर्न रहेगा. Otherwise, if it is a 3 degree, third degree equation, so it should intersect the x-axis at 3 different points. But you can see here, it is touching at point 2. That's why we are getting 2 values of lambda. Okay, same 2 and 2 and 3 is there. Okay, so either this way or that way you have a curve. Okay, if you use the Excel sheet, I hope you know you know how to plot the curves in Excel. आता है? ठीक है, ट्राई करके देख लेना, गूगल कर लेना. आजकल तुम्हारी जनरेशन वैसे भी ऑनलाइन में काफी कुछ पढ़ चुकी है. ठीक है, तो एक बार प्लॉट करके देख लेना. आइदर यू विल गेट फर्स्ट कर्व और सेकंड कर्व. ओके, व्हिच इज इंटरसेक्टिंग the x-axis at location 3 and it is touching at location 2. Okay, so this lambda 1, lambda 2 and lambda 3, they are called as eigen values. Okay, हमको आइगन वैल्यू से कुछ लेना नहीं है. हमको क्या चाहिए? हमको x की वैल्यू चाहिए. Okay, because x is basically denoting your unknown displacements, right? So now how to get the eigen vectors? They are called as eigen vectors. So for this purpose, we have to substitute the values of lambda in the equation at as lambda 1, then lambda 2 and lambda 3, and then we have to find out the x values. Okay, so let me go back. I think we have taken this particular problem. So so let me copy this. It is going to reduce my work. Okay, so the same equation or same matrix, I am pasting it over here. Okay, so now here I am going to substitute the value of lambda. Okay, so here lambda as lambda 1 and its value is 3. Okay, so if you substitute the value of lambda as 3, what is going to happen? So our original equation was something like this: a into x equals to 0. ये था, और a को हमने क्या लिखा? A is a minus lambda times I. Now this will be into x equals to 0. Okay, so this a minus lambda times I is nothing but this equation. Correct? So if I substitute the value of lambda as 3, okay, so what I should get over here? This is 3 minus 3 is 0. Okay, this is 10, this is 5, this is minus 2, this is minus 3, minus 3, this will be minus 6, this will be 4, this will be 3, this will be 5, and then 7 minus 3, that is 4, into you have x1, x2 and x3 equals to you have 0, 0 and 0. Okay, so now how to get these values of x1, x2 and x3, because we are interested in what is x1, x2 and x3. So for this purpose, now you have to generate the equations. Okay, so if you multiply the first row with the unknowns, so what you are getting is something like this. That is 0 times x1 plus 10 times x2 plus 5 times x3 equals to 0. Okay, so if you solve this, okay, if you solve this, what you will be getting? So this will be 10 times x2 equals to minus 5 times x3, or I should put minus sign over here, that will be better. Okay, so one and the same thing. And if you can substitute the value of x3, then x3 can be minus 2 times x2. Can I do it like this? Okay, so x2 or rather x3 is nothing but minus 2 times x2. This is one expression which is relating the value of x2 and x3, which I am obtaining by taking or by solving the first equation. Okay, so now if I go for the second equation, okay, so if I go for the second equation, so second equation is something like minus 2 times x1 minus 6 times x2 minus 4 times x3 equals to 0. बराबर है? ठीक है? So in this I already know the value of x3. So x3 is basically minus 2 times x2. बराबर है? So if I solve this, so this is minus 2 x1 minus 6 x2 minus 4 times x3 is basically minus 2 times x2 equals to 0. Okay, so if you once again solve this, this is 2 times x1 minus 6 times x2, and this will be now plus 8 times x2 equals to 0. And again if you reduce this, so 2 times x1 plus 2 times x2 equals to 0. बराबर है? So from this particular expression, I can correlate what is the value of x1. So for this purpose I am taking this x2 over here. So this is 2 times x1 equals to 2 times x2. बराबर है? So in short, x1 is nothing but your x2. Okay, so now we have two relationships. Okay, so we have two relationships with us, right? One is relating x1 with x2 and one is relating x3 with x2. So now we have the values of x1 and x3 in terms of x2. Okay, so now what I can do over here is, if I substitute the x2 value as 1, okay, if, so this is again if x2 equals to 1, okay, what will be the value of x1? 1. This is from this equation, बराबर है? And what will be the value of x3? Minus 2. Okay, so this is nothing but your eigenvectors. Okay, but this eigenvector is for lambda 1, its value is 3. Okay, so you can see this is a truss problem, you can say, and we have now a solution, that is the deformation at 3 points x1, x2 and x3. It is 1, 1 and minus 2. Okay, so we are basically relating the terms, that's it. Okay, so this is one such possible solution where if you substitute the values, you will be getting the answer as 0. Okay, now another solution we have, that is lambda 2 and lambda 3, both values are 2. If they are different, then we have to solve them independently. So if you substitute both values as 2, what is going to happen? Let us see. Okay, so this was my original matrix. Okay, so now here I am going to multiply this with x1, x2 and x3. This should be equals to 0, 0 and 0. So now in this case, lambda 2, which is also lambda 3, the value is basically 2. Correct? So now again you have to just substitute the values over here. So now in this particular case, so this 3 minus 2 is 1, this is 10, this is 5, this is minus 2, this is minus 2, minus 3 minus 2 is minus 5, minus 4, this is 3, 5, and I think this is also 5. Okay, and you have x1, x2 and x3. This should be equals to 0. Okay. So now for the second case, you can have, or you have to solve this so that you can get the values. Okay. So let us try to solve this. Okay. So if you take the first equation, okay, so if you take the first equation, so let me write down the first equation. So this is 1 into x1 plus 10 into x2 plus 5 into x3. This should be equals to 0. Okay. So now earlier it was easy because one term was getting 0. Okay, but now here all the terms are there. So now we have to just solve this. Okay, so in this case, you can use your Gauss elimination method. Okay, you can eliminate that and then you can get the solution. Otherwise, we can also solve it manually. Okay, so for example, if I solve this equation for x3. Okay, or maybe let us say we'll solve this for x1. Okay, so what will be the x1 value? So x1 value will be minus of 10 times x2 minus 5 times x3. Okay. Then if you generate the second equation, so second equation is minus 2 times x1 minus 5 times x2 minus 4 times x3 equals to 0. Now we already know the value of x1. Okay, so you can substitute the values of x1 over here. So minus 2 into x1 is minus 10 times x2 minus 5 times x3. This will be 5x2 minus 4x3 equals to 0. And if you solve this, so I think you will be getting plus 20x2 plus 10x3 minus 5 times x2 minus 4 times x3 equals to 0. बराबर है? Okay, so now you can take out some of the terms constant. So this will be 15 x2 and this will be I think plus 6 times x3 equals to 0. बराबर है? So now you can correlate x1 or you can correlate x2 in terms of x3 or this in terms of that. Okay, but this is not going to solve my purpose because I don't know the value of x1. Okay, so what I can do is you can substitute the correlation in between also. Okay, so what I'll do, I will go for another equation, that is the third equation. So this is 3 times x1 plus 5 times x2 plus 5 times x3 equals to 0. Okay, so if you rewrite the terms, so x3 times x1. Okay, तो x1 क्या है तुम्हारा minus 10 times x2 minus 5 times x3. Okay, plus 5x2 plus 5 x3 equals to 0. So this will be minus 30 x2, this will be 15 x3 plus 5 x2 plus 5 x3 equals to 0. So this is 30 and this is 5. So this is minus 25 x2 minus 10 times x3 equals to 0. Okay, so now you can establish or you can solve this for x2 and x3. Okay, so you have two equations. So can you solve this? So just solve x1 and x2 and x3. So if you solve this, you should get x2 as minus 2 by 5 times x3. Are you getting this? Okay. So now you have a relationship between x2 and x3. Okay. So if you substitute this x2 and x3 over here, so you should get the value of x1 in terms of x3. कितना आएगा? Minus x3. ठीक है? So here now we have a relationship between a relation or the equation for x2 and x1 in terms of x3. Okay, so जो right hand side है that should be constant. Okay, so if I consider the value of x3 as 1, okay, so if I consider x3 as 1, so my x2 will be this, that is minus 2 by 5. Okay, and what about x1? X1 is nothing but minus of x3, so this will be minus 1. So these are nothing but eigenvectors for lambda equals to 3. 3 है 2 है ये, I think this is 2. ठीक है, so this eigenvectors is nothing but your unknown displacements. Okay, and you can consider this lambda as kind of a frequency. Okay, so depending on that frequency, you are having a structure which is vibrating. Okay, and accordingly you are getting the solutions. Okay, I hope this is clear to everybody. Okay, so we'll take one more problem tomorrow. Meanwhile, just let me take your attendance. Okay, already time is up.